Friends, welcome to the subject Database Management System. Today's session is session number 37. And the topic is Relational Databases and Relational Database Schemas. Point number 1. The definitions and constraints we have discussed so far apply to single relations and their attributes. A relation database usually contains many relations with tuples in relations that are related in various ways. Students, you very well know that we have studied relations, tuples and attributes. Here relation means table. Tuple means record of a table. So you can understand that way. In this section, we define relational database and relational database schema. Point number 4. A relation database schema, yes, is a set of relation schema where S is equal to set of R1, R2 up to Rm and a set of integrity constraints which is called as IC. So students, relational database schema consists of number of relations and it will follow integrity constraints. Point number 5. The relational database state DB of S is a set of relation states DB equal to R1, R2, Rm such that each Ri is a state of capital Ri, that is relation, and such that the Ri relation states satisfy the integrity constraints specified in IC. Figure 5.5, which is available in the next slide, shows relational database schema that we call. So students, here relational database schema is company and the relation in that schemas are employee, department, department locations, project, works on and dependents. So these are various tables in the company database. Students, you should understand relation as a table. Point number 7. In each relation schema, the underlined attribute represents the primary key. So students, we have here schema diagram for company relational database schema. So students, you find your table, employee table, department location relation, project relation, works on and dependent. Students, when we study, we will intermittently use the term table and relation, but they are different. So employee table consists of, or employee relation consists of F name, middle initial, L name, SSN, birth date, address, sex, salary, super SSN, DNO. Students, so these are the attributes of relation employee. Similarly, there is a department relation whose attributes are D name, D number, manager SSN, manager start date. Similarly, department location is a relation whose attributes are D number and D location. Project relation has got attributes P name, P number, P location and D number, that is department number, because every project is controlled by department. Works on has got attributes such as ESSN, PNO, hours. So here ESSN stands for Employees Social Security Number and PNO stands for project number. And the last relation is dependent, whose attributes are ESSN, dependent name, sex, birth date, that is B date, and relationship. Students, here ESSN is employee SSN whose dependent are there. Dependent name, okay, these are dependents of an employee. So in all, you can find that in a relation schema, okay, company, there are tables like employee table, department locations, project, works on, dependent. So there are 6 tables or 6 relations in, okay, company relational database. We will use this schema and database state in this chapter and in chapter 6, that is the next chapter, which is titled as Relational Algebra, and also through the chapters such as Introduction to SQL. Now let us know what is valid database state and not valid database state. When we refer to relational database, we implicitly include both its schema and its current state. Point number 2. Not valid, that is invalid database state. A database state that does not obey all the integrity constraints is called not valid. Next, valid database state. A database state that satisfies all the constraints in the defined set of integrity constraints is called a valid state. So students will study figure 5.5, which you have seen already, which is a schema diagram for the company relational database schema. So point number 1, in figure 5.5, the D number attributes in both department and department location stands for the same real world concept, that is the number given to a department. Point number 2, that same concept is called DNO in employee and DNUM in project. So student department number is called in different way in different relations. Point number 3, attributes that represent the same real world concept may or may not have identical names in different relations. Alternatively, attributes that represent different concepts may have the same name in different relations. For example, we could have used the attribute name such as name, NAME, for both P name, that is the project name, P name of the project, and D name of the department. In this case, we would have 2 attributes that share the same name but represent different real world concepts, that is project names and department names. Attributes names in relational database. In some early versions of the relational model, an assumption was made that the same real world concept, when represented by an attribute, would have identical attribute names in all relations. Point number 2. This creates problems when the same real world concept is used in different roles, that is the meanings, in the same relation. Point number 3. For example, the concept of social security number appears twice in employee relation in the figure 5.5, once in the role of employees SSN and once in the role of supervisors SSN. The student in the employer relation, you got SSN appearing twice. One is the employee's SSN, another is supervisor's SSN. Point number 4. We are required to give them distinct attribute names SSN and super SSN respectively. Here students, SSN stands for employees SSN and super SSN stands for supervisors SSN because they appear in the same relation and in order to distinguish their meaning. DBMS language and constraints. Each relational DBMS must have a data definition language, that is DDL, for defining a relation database schema. Point number 2. Current relational DBMS are mostly using SQL for this purpose. Point number 3. Integrity constraints are specified on the database schema and are expected to hold on every valid database state of that schema. In addition to domain, key, and not null constraints that we studied earlier, two other types of constraints are considered part of relational model are entity integrity and referential integrity constraints. Students, these two will take up in the next class. Students, today we have taken up database, relational database schema. Okay, this is a new concept. That means in a database there are a number of relations and each relations are somewhat related. More about this we'll study in the next class. Thank you.